So just to start off with a quick note on eigenvalues, eigenspaces, and bases for eigenspaces, and an eigenvector basis for, in this case, R3. So this matrix from diagonalization 2 has two eigenvalues, lambda equals 2 and lambda equals 3. And I said find a basis for the eigenspace corresponding to each eigenvalue. So I'm looking for two different bases, one for lambda equals 2 and one for lambda equals 3. So this question says find a basis for the eigenspace corresponding to each eigenvalue. So since there are two separate eigenvalues, I'm looking for, in this phrasing, two separate bases. One for each eigenvalue. So in this case, I'm looking for two separate bases, one for each eigenvalue. And so they are whatever they are. So for lambda equals 2, I was looking for, I think 2 is the one that had the one-dimensional eigenspace. And then for lambda equals 3, there was a two-dimensional eigenspace because A was diagonalizable. So I'm looking for two separate bases. I think it was -1, 1, 0. Spelled 1 wrong. Oh, I could have saved it by just writing it in the other order. Oh well. And I think this was 1, -1, 1. So there are the answer to find a basis for the eigenspace corresponding to each eigenvalue. That means I'm looking for two separate bases, one for each eigenspace. So this is separate from, say, find an eigenvector basis for R3. Find an eigenvector basis for, it have to be R3 in this case, R3. This means find one basis, a basis for R3. So this is a different question. In this case, basis made up of eigenvectors would be one basis. So I would just want this vector, 1, -1, 1, -1, 1, 0, -1, 0, 1. Here is a basis of eigenvectors for R3. This is useful in its own right, but one of the things that we want to get across in these early eigenvector problems, I guess they're also the late eigenvector problems, in these early eigenvector problems, is that the bases or the eigenvectors correspond to particular eigenvalues. 1, -1, 1 is an eigenvector for 2 and not for 3. So I want to make sure that those things are lining up. If we wanted to, for example, diagonalize the matrix A, we could put diagonal entries of 2, 3, and 3, and that would determine how we construct the matrix P. That would mean if I put 2 in the first column, then this 1, -1, 1 needs to be the first column of the invertible matrix P, and so on. Another thing to note is that when if we name a basis, we have to note that B is a set of vectors and not a matrix. So when I write B is this set of vectors, we need to note that B is a set of vectors. Not a matrix. Since B is a set of vectors and not a matrix, we can't use B in a matrix equation. So since B is a set of vectors and not a matrix, the equation Bx equals P doesn't make any sense. it gets the point across, but you're not talking about when you write the letter B as the name of a basis, you can't use B as the matrix. So B is the name of a basis. B is a set of vectors, not a matrix. I can't put B into a matrix equation because B is not a matrix. B would have to be a matrix. Now, we could define a matrix that we using these three vectors as its columns. We could define a matrix separately, but if we use the letter capital B for it, we're making an incredibly bad decision because now script B is the name for this basis, but if we're typing stuff out, maybe all we have is capital B. And if the only difference between your variables is one is italicized and one is not, that's going to be very, that would be a very poor way to communicate. That would be a very poor way to communicate your ideas. So in this case, B is a set of vectors. If we want, we can define a matrix using these vectors. So if these all have names, B1, B2, and B3, we can define a matrix with these vectors as columns. Oops. So I could say the matrix A is B1, B2, and B3. Once we define this set of a matrix, once we define a matrix using this set of vectors, now I can write the equation AX equals P. That makes sense because A is now a matrix, but I had to write that down. Any questions? Also notice the difference in form when I use the braces and commas in a set of vectors, but when I'm defining a matrix, it's brackets and no commas, just spaces between them. Because when we're writing a matrix, I didn't write a matrix. When we're writing a matrix, we don't put commas in between the columns. Oh, I also shouldn't use the letter A for this matrix, should I? Because A is the original. So that was a bad choice on my part. So I'll call this matrix Q. Now I can use this matrix in a matrix equation. So an argument could be made that if you wrote Bx equals P, where B is the name of, was this set of vectors, an argument could be made, well, the reader will just assume that I'm making a matrix out of these vectors. And you'll get the point across, but that's not always sufficient. Math is a very precise language, and we should practice speaking it precisely. So that's why I take off points every time I see things like this. Like, oh, B is not a matrix. B is a set of vectors. Because I want to stop this kind of casual association between things where the reader has to do some work to say, oh, they must mean take these columns and put them into a matrix and put that into an equation. You don't want to put that burden on your reader. So that's why I do things like that. Any questions? Writing things like this and hoping that people will put this together is bad practice. And it would be like saying, I'm going to go pilot my car down to the store and get something. It gets the point across. You know what is about to happen. I'm about to drive my car, but I'm not using the right words. The words aren't going with the correct things. Any questions? Okay, so that's one of the points that I wanted to open with today. I wanted to clarify the difference between find a basis for the eigenspace corresponding to each eigenvalue. So that means I need a separate basis for each of those two eigenspaces. And the other question, which could be find an eigenvector basis for R3. You could say, or explain why no such basis exists. So since A is, the answer would be there is no eigenvector basis for R3 since A only has 2 linearly independent eigenvectors, for example. Any questions? Great. I think that was the only thing that I really wanted to point out about the quizzes on diagonalization. So I'm going to pause this video. So we had a nice little short opening video. I'll pause the video here, and we can go over any other questions that we want, since today is the last day.